You have trained a new classification model, and its accuracy is 99%, which sounds amazing, right? But what if I told you that 99% accuracy could be completely useless? This often happens with imbalanced datasets like in fraud detection, where the event you are looking for is rare. If your model just predicts the majority class every time, it will be 99% accurate, but will have failed its purpose. Accuracy can be a liar, so today we are diving into a much more honest and robust metric called the F1 score. To understand the F1 score, we first need to master its two building blocks, which are precision and recall. And to understand those, we need the confusion matrix, which shows where our model got things right and wrong. True positives are when the model correctly predicted the positive class, like identifying a fraudulent transaction. True negatives are when the model correctly predicted the negative class, like identifying a legitimate transaction. False positives occur when the model incorrectly predicts the positive class, which is a type 1 error. False negatives happen when the model incorrectly predicts the negative class, also known as a type 2 error. Precision asks a simple question: of all the positive predictions we made, how many were actually correct? The formula for precision is true positives divided by the sum of true positives and false positives. Recall, on the other hand, asks, of all the actual positive cases in the data, how many did our model find? Recall is calculated as true positives divided by the sum of true positives and false negatives. Here is the crucial part. Precision and recall are often in a tug-of-war, which is the precision-recall trade-off. If you want extremely high recall, you might lower your standards and catch all the real positives, but you will also flag many non-positives. If you want extremely high precision, you can be incredibly strict, but you will miss many of the more subtle positive cases. So which is better? You might think you can just take the average of precision and recall to find a balance. This is a bad idea, because a model with high precision and very low recall would get an average that looks deceptively okay. This is exactly where the F1 score comes in. The F1 score is the harmonic mean of precision and recall. The F1 score is calculated as 2 times precision multiplied by recall, divided by the sum of precision and recall. The harmonic mean is a type of average that is heavily weighted towards the smaller value. To get a high F1 score, both precision and recall must be high, because a low score in one will drag the entire result down. Let us go back to our example. With 1.0 precision and 0.01 recall, the F1 score is about 0.02. As you can see, the F1 score correctly tells us this model is terrible, while the simple average was misleading. Let us walk through a full calculation and imagine a spam filter that reviewed 1,000 emails. Our model correctly flagged 90 spam emails, incorrectly flagged 10 good emails, missed 10 spam emails, and correctly identified 890 good emails. First, we calculate precision, which is 90 divided by 100, giving us a score of 0.90. Next, we calculate recall, which is also 90 divided by 100, resulting in a score of 0.90. Now we combine them for the F1 score, which after calculation also gives us a result of 0.90. An F1 score of 0.90 is excellent, and it shows our model has a strong, healthy balance. So to summarize, remember that accuracy can be misleading for imbalanced classes, where one group is much larger than the other. The F1 score combines both precision and recall, and this provides a single, more reliable metric for evaluation. It uses the harmonic mean, which punishes extreme values, ensuring a model is rewarded only if it is strong in both areas. If this breakdown helped you, be sure to hit the like button and subscribe to BlackboardAI for more deep dives.